Suppose you have 100 feet of fencing that you want to enclose for a garden or a pasture for your animals or whatever. So you want to maximize the amount of area that you can enclose with your 100 feet of fence. So you know that maybe this side, we'll call this side X. And then because all of the sides of your fencing have to add up to 100, then we know that there's going to be 100 feet of fencing to use for two values of X plus some other unknown value, also times 2. But if we want to rewrite Y in terms of X, then we can actually get a formula that tells us what Y is going to be equal to. So let's move that X over to the other side by adding a negative 2X to both sides. Now we'll divide both sides by 2, and we can see that this side Y is actually just this quantity 50 minus X. When we know that the area enclosed by a rectangle is the width times the length. So our area, dependent only on this X variable, is going to be X times 50 minus X. Cool. So now we want to find the maximum value for that. Well, let's consider what this expression, this side of the equation, could also be written as well. If we multiply out the X, 50 times X minus X squared. That now is a quadratic equation because we have our variable raised to the second power. Well, we know that a quadratic equation either has to have a parabolic curve like a smiley face or a parabolic curve like a hill. If our expression here has the smiley face, well, then the max is going to be at the two ends. If the curve has more of a hill shape, well, then that max is going to be right there in the center of our hill. And because our A term here, so the number that is implicitly multiplying times the X squared is -1, it's going to be a hill, not a smiley face. So we had that our expression for the area of our fenced in pasture, garden, whatever, is -X squared plus 50X. So now if we can identify the zeros of this expression, we would be able to plot on a graph the first zero and the second zero, wherever those may be. And then, because we know that the A is negative, it's going to have a hill. This is again assuming that those zeros do exist. So let's go right to the quadratic formula, which states that x1 and x2 is equal to -b plus or minus the square root of b squared minus 4ac, all divided by 2a. Looking at this, our a is -1, b is 50, and c is 0. There is no c. Now we can start plugging these values in. So x1, x2 is equal to a -50 plus or minus the square root of 50 squared minus, well, ultimately it's going to be 0 because 0 times anything is 0. So the 4ac goes away. All over 2 times a -1. We start simplifying. It's going to be a -50 plus or minus the square root of 50 squared, so that's actually 50, all divided by a -2. So the zeros of our hill, of our parabolic curve, is going to be -50 minus 50 divided by -2, or it's going to be -50 plus 50 divided by -2. So our x1, x2 values going to be -100 divided by -2, or 0 divided by negative 2. In other words, it's going to be 50 and 0. So now we know that along our x, plots a of x, we have a first 0 at x equals 0, and the other 0 at x equals 50. Let's just call this spot right here our 50 value. And our hill is going to look something like that. And any parabolic curve, so any graph that represents an, ax equals something x squared is going to be symmetrical. So the midpoint of these two zeros, which the midpoint between 0 and 50 is 25, has to be the maximum value for our hill. So what would be a of 25? So we have our negative 25 squared plus 50 times 25. Let's get to simplifying this expression. So a of 25 is going to be a negative 25 squared. That's a big number, but these have something in common. So let's go ahead and factor out that 25 first. That way I don't have to do big multiplications. So we'll factor out the common term, 25. We would be left just with a negative 25 plus 50. Well, that's much simpler to do because that's just 25. So I still have to do 25 squared, but that's all right. That's not too bad. Go ahead and 5 times 5, that's 25 again. A lot of 25s here. 5 times 2 is 10. Add the other 2 is 12. Hold the place with the 0. 2 times 5 is 10. Bring up the 1. 2 times 2 is 4. Add the 1 is 5. So 25 squared is 625. And just to kind of give us a sense of security that this is a maximum area that can be enclosed by our 100 feet of fence, let's check what the area from an x side of 20, which would mean that y side of 30, would be. I'm going to use the same, factor that out. So we'll be left with that negative 20 plus 50. So we'd have 20. Negative 20 plus 50 is 30. 20 times 30 is only 600. And yes, you can see that a of 25, which is the 625, is in fact greater than a of 20. So again, that's not really proving that our a of 25 is our maximum, but at least it's a nice sanity check that at least there was a value along our parabolic hill curve that is less than this value that we picked at 25. A much fancier non-algebraic way to find the maximum of our a of x would be to bring in calculus. So we had found that our expression for the area enclosed by our fence was negative x squared plus 50x. So if you're familiar with a little bit of calculus, then you can easily take this derivative. So a prime, the first derivative of x, would then be negative 2x plus 50. And a minimum or maximum value of this derivative occurs when it equals 0. So that would imply that 0 has to equal negative 2x plus 50. Well, let's add a 2x to both sides. So that'll cancel out this negative 2x. Leave just a 50. Well, and that means that the min or max occurs at x equals 25. So now this actually proves that a min or max occurs at that x equals 25 value. So now checking and comparing a of 25 versus a of 20 would then be a way to show that the a of 25 is a maximum value, not a minimum. If you found this little walkthrough helpful of how to maximize the amount of area you can enclose with a fixed length of fencing, and you have other questions, or maybe would like to reach out for your own personal private tutoring, you can get a hold of me, jackalbruitt@gmail.com, or go ahead and drop a comment below with any of your questions. I'd be happy to do a follow-up video specifically tailored to your specific mathematics problem. But until next time, make sure to be mindful of those pluses and minuses when you distribute inside your parentheses, and have a great day.